Hi, I am Mali. Welcome to the channel. Imposing consistent light is a powerful and versatile tool that has the potential to change the way we interact with and manipulate digital images. With ICLight, you can create consistent and realistic lighting changes, opening up new possibilities for creative expression and practical applications. For added complexity, directional lighting can be directly integrated into the latent space during sampling. Running Ollama locally and incorporating the image prompt adapter allows for sophisticated manipulation and control over the reference background. The workflow compensates for the inherent degradation of text detail introduced during generation. Detail loss is common when injecting the subject into latent space. I use a unique method to transfer the details, even on the upscaled 4K images, without compromising the lighting on the relight subject. Let me show you how to create the workflow, along with some creative techniques and hacks I use to get these results in Comfy. A huge thank you to all our amazing paid channel members. Also, a special shout out to Liuman Zhang for developing imposing consistent light. This tutorial is not for beginners, and you need prior know-how on various aspects of ComfyUI. ICLight is based on Stable Diffusion 1.5. However, the workflow will output SDXL resolution, which is further passed on to an upscaler. We transfer the details in both stages, before and after upscale. So, there are two workflows. One is for the SDXL output, and the other is only for transferring details after upscaling. Before starting, update ComfyUI to the latest version and install all necessary custom nodes. This workflow also requires Ollama, which needs to be installed separately. Seth will guide you through the Ollama setup process.
Hi, Seth here. Ollama is an open source project that allows you to run large language models locally on your own machine. We use it to get detailed prompts for the background reference and the product. We would then concatenate the conditioning and pass it on to the sampler. Go to the Ollama website and click on Download. The tutorial is recorded on Windows, so I will download the Windows version. Once you download the file, run the install and open the command prompt from the Start menu. We need a vision model that understands images. I have already downloaded it to the system. Back on the web page, go to Models. I will use Microsoft's Large Language and Vision Assistant model. Before starting Comfy, you must start the command prompt and run the model. The first time you run this command, it will download the model. And that's it. Keep the command prompt minimized while using the Ollama node in Comfy. Once done, type in /by to unload the model and exit the command prompt. Back to Malif for the tutorial.
This is the latest version of Comfy. You can access this interface by going to Settings. At the top, you can see the Beta menu and Workflow Management. Select Top or Bottom to enable the Beta interface. This workflow requires about 16 custom nodes. They all work with the latest Comfy-compatible Python and PyTorch versions. The Impact Pack is used for preview bridge masking, integer, and switch nodes. I use the wasNode suit to save the prompt to a text file. However, you can avoid it using a Python GOS or Comfy Roll Studio node. I will show all the options while building the workflow. The show text nodes for the Ollama prompts are from Python GOS. Comfy Roll Studio nodes are used extensively. For background generation, you also need the IP adapter plus node. Comfy Math for the resolution calculations. And ArtVenture for the Gaussian blur filter. RG3 for the seed and comparison. Essentials for image resize, mask previews, and KJ nodes for organization and masking options. Layer style nodes are essential for the workflow. For masking and segmentation, I will use the bilateral reference network nodes from XOXO, which are licensed under GPL3. For ICLight, I am using the native implementation from Chinlehu. This is not the same as the implementation by Kajai. Take a note of that. Layered diffusion is required even though no nodes are used, otherwise, the ICLight will give an error. Ollama is used for reference background and product conditioning, and lastly, ResAdapter is used to go beyond the SD 1.5 resolution and keep the generation from hallucinations. Go to this Hugging Face page. From the Files and Versions tab, download all the given models. And put them under this folder within your Comfy install. If you don't have this folder, create it. Now open another web page. Note that these ICLight models are the layered diffused versions. They are different from the standard ICLight models. In the Model.U.NET folder, create a new folder named IC-Light, as shown, and put both the model files here. For one of the masking nodes, you need to download the Vision Transformer image matting models and JSON files. Go to your Comfy Models folder again and create a new folder with the name VitMat, all small caps. Save both the JSON, bin, and safe tensor files here. Add two load image nodes. One will be for the product you want to relit and the other for the reference background. We are going to make the resolution completely dynamic. You will understand as we build the workflow. Add the nearest SDXL resolution and connect it with the product. Now add the SDXL resolution, and we will use this for our custom canvas resolution. Add a switch any node and rename it to width. Duplicate for the height. Make the connections. SDXL in input 1 and nearest SDXL in input 2. So the input 1 would be a custom resolution. And the input 2 would be whatever is the product size, converted to nearest SDXL. Convert the widget select to input. Add an impact integer node and make the connection. This will allow you to choose a single value 1 or 2 for both the width and height. Let's select 1216 by 832 resolution for now. Any subject or object passing through ICLight should have a distinct gray background. With the color gradient node, we can generate this specific gray background. The width and height will be taken from the width and height switch, so convert the widget to inputs and make the connections. The workflow is going to be big, so let's use the set node from KJ nodes, and set a width and height value that we can easily use later on in the workflow. Add a preview and change the start and end hex color codes to this specific gray tone. I will use two versions of the ByRefNet background removal nodes. One will be from Zoe, and the other will be the layer mask. Ensure that the EP580 model is selected as it performed better in my testing. The second one is an even further improved version. It has some fine-tuning abilities and uses VitMat. The reason for using the same model in two different nodes is that both performs differently. In my testing, most of the masking was done correctly with the Zoe node. However, in very specific cases, I preferred the Ultra one. And sometimes, the Zoe performed better than the Ultra. Add an image resize node, the one that has the wrench icon. This will connect with the product. Also, convert the dimensions into inputs. Okay, so this is very important. Do not connect the product resize with the custom resolution. You do not want to get the product cropped. That will happen if the product ratio differs from the custom resolution ratio. Connect the product resize with the nearest SDXL resolution. Change the interpolation to lengths, method to fill, crop. Now connect the product resize with both the ByRef nodes. Let's select a sample product image. This photo is taken from an iPhone. I prefer white backgrounds and surfaces, as they help if the material is glass. They will minimize the reflective colors. No additional lighting was used. Basically, just point and shoot at a specific angle. In this particular image, the masking is perfect for both nodes. Keep the Zoe node as the default, as it will suffice most images, and switch to the Ultra only when required. Also switch the VitMat to local, as we have already downloaded the models. Let me show you another image that is difficult for the model to segment. So this is glass, and I want the reflections to be as neutral as possible. Again, this is simply point and shoot. I have to test the system's performance and its limitations in segmenting the object. Now, you can clearly see the difference in the node's performance. The Ultra does a better job with the default values. It removes the whites more effectively. You can fine-tune the masking further with these settings. Let's revert back to the previous image, as it has a lot of text, and I want to show you how to transfer the details correctly. Add two switch any nodes. We need both the image and the mask. So, one would be the image segment, and the other would be the mask segment. Like before, convert the select to input and connect it with the impact integer, as we need the image and the mask to be the same. For clarity, rename the integer node to select mask input. And rename the previous integer to select resolution input. I have organized the workflow in groups. We have the product and reference background, resolution calculation and masking. Add the Image Blend Advanced version 2 node. This powerful node will allow us to resize and place the product against the background. Turn off the invert mask. Connect the image and mask segment outputs to the layer inputs. The gray background generated using the CR color gradient node will connect as the background layer input. Here, I can now scale the product image and position it by adjusting the X and Y% values. 50% means it's centered. To move it towards the left, let's adjust the value to 20%. Let's bring it further down the Y-axis and reduce the scale by another 10%. Adjusting the rotate value will rotate the image segment. A plus value turns it anti-clockwise, and a minus value turns it clockwise. The gray area here will be replaced with your reference background. We won't just cut and paste the background. We will pass this entire composed image to Latent so the background can be generated with the product's perspective. And all this will go together through ICLight. After deciding the composition, we must resegment the product and separate the mask and image. This step is necessary as we use the composition mask to transfer the details in the final generation. We cannot use the mask from the original image as the size and position of the original image mask won't match. Copy these 7 nodes and paste them with connections. Connect the blended output to the by-ref net nodes for the image and mask resegmentation. I'm just going to rearrange a bit here. For the resegmentation, the zone node always mainly work. Still, the Ultra option is there in case of any specific image or if you want to fine-tune it. We will need this mask segment later on. So connect it with a set node. I am not going to connect these further. First, let's work on the Ollama conditioning. Duplicate the product resize and rename it to background resize. Connect the dimensions from the switch. And the background load image. Connect this with a set node as reference background. Add an Ollama vision node. This one is for the background. As shown earlier, the Ollama should be running. Open the URL in a new window, and you can confirm if it's running or not. Select the vision model. Rename the node to background for clarity. Take note of the prompt. Describe the image in extreme detail. Include atmosphere, mood and tone, and lighting. Write the description as if this is a background for a product advertisement. Obviously, you will tweak this if you are using it for something else. But this style of prompt will give long, descriptive descriptions that help. Duplicate this. We want a separate description for the product. Let's move these nodes just above the blend node. We will connect the image segment output from the masking group to the product Ollama input. For the product, change the prompt to describe the product in the image. Write the description as if you are a product photographer. Tweak it as per use case. Connect both the Ollama nodes with a show text node. As an example, I am going to use this background. The workflow is designed to throw in any background without requiring manual prompting. As you can see, it describes the product in detail. It doesn't matter if some of the labeling is wrong. You can, of course, manually tweak this prompt and take only parts of it. However, I have tested using many images and products, and the outputs have an excellent success rate. I recommend just leaving things as they are. We will concatenate both these prompts and then pass them on through conditioning. This way, it looks like we are describing a product perfectly blended with the background, and overall, it's a product advertisement. That's what the AI will understand with the conditioning. Use a CR text concatenate node. Connect the product first, then the background. And further connect it with a show text node, which would be the final conditioning. Rename all the show text nodes for clarity. The thing with Ollama is that it's generative. You may get a different prompt description if you close and reopen Comfy. So, if you are working on a background and like the generation, saving the prompt in a text file is advisable. First, add a CR text node and rename it to custom conditioning. To maintain consistency for the tutorial, I will use the prompt that Ollama previously generated. To save the final prompt, add a save text node from the was node suite and connect it with the final positive conditioning output. By default, it will create a new folder with the date. Let's change that to ICLight prompts. And the file name as image prompt. The was node suite is only used to save prompts. If you don't want to install the custom node, use the save text from Python GOS. I prefer the was suite one. Here, you choose the directory and file name and keep append as new. From this point, the workflow gets a bit complex. I will try to go as slow as possible. To review the groups, we have product composition, composition masking, Ollama conditioning, and the save Ollama prompt group. Below the save prompt group, add a load checkpoint node. ICLight only supports SD 1.5. I am using the Juggernaut Aftermath checkpoint. All the settings for the samplers will be based on this checkpoint. Search and add the ResAdapter node. Change the ResAdapter to version 2 SD 1.5. There is no need to change any other settings. The ResAdapter will reduce duplications and hallucinations in the generation. I am using an SD 1.5 checkpoint to generate SDXL resolution images. I will not explain the technicality of the ResAdapter. For this workflow, you should leave all the values at 1. You can read about the ResAdapter on the GitHub page. We'll leave the link in the description. Connect the model and clip. Put a set node for the VAE. Now we can add nodes for the ICLight. First, we are going to create an empty latent. Convert the dimensions and use the switch resolution via the Get nodes. Connect the width and the height. This empty latent goes to the case sampler, but not directly. Connect to a VAE decode first. And use the Get Node shortcut. Now add an image composite masked node. Connect the empty latent decode to the destination. The mask segment from composure masking group to the mask. Take the image segment output and split the image with alpha. We are doing this to split an image into multiple parts while preserving each part's transparency information, the alpha channel. This will now connect to the source input. This gets passed on to the K-sampler latent. Let's have a look. We will connect this to the K-sampler a bit later. For now, add the ICLight node. The ResAdapter model output to the ICLight apply model. The IC model will be from UNet. For this workflow, we need to use the FC model instead of the FBC model. The FBC model is typically utilized when a direct background is provided as input, but in our case, we are not using a direct background. Instead, we use a reference BG to create a background on the empty latent. Connect the image segment with the ICLight apply mask gray. Use the mask segment output for the alpha mask input. This output goes to the ICLight for relighting. Instead of the normal VAE encode, connect it with the argmax VAE encoder. In a VAE, the standard encoding process maps an input to a distribution within a continuous latent space. The argmax variant, however, selects the single most probable point from this distribution, resulting in a discrete representation. This can enhance the interpretability of the latent encoding by focusing on the most salient features. This latent output connects with the conditioning concat in ICApply. It is designed to concatenate different conditioning inputs for the image generation process. The ICLight apply connects to the IPAdapter advance. Add the IPAdapter and ClipVision model nodes. Choose the Plus SD 1.5 model. You should have some prior knowledge of how to set up the IPAdapter models. Choose the VIT-H ClipVision model. Use the Get node to get the reference background, and connect it with the image input for the IPAdapter. Change the IPAdapter weight to 0.47. The weight type should be ease and out. The embeds underscore scaling would be K plus V with channel penalty. Connect the image composite masked output to a VAE argmax encode node. Later on, I will add multiple latents with a switch. For now, add the Get node for VAE. Add a normal K sampler. Connect the latent and the model. Now add 2 clip text encode nodes. The negatives are copied and pasted from Civet AI for the Juggernaut Aftermath model. Connect the negative conditioning and convert the text to input in the positive conditioning. We will now connect the Ollama group to a switch. Add a CR text input switch. Rename as shown. Connect the switch to the positive conditioning. The text concatenate will connect to text 1. Rename to Ollama. Custom conditioning to text 2 and rename to custom. Connect the positive conditioning. Convert the seed to input and use an RG3 seed node. We'll use a random seed. Add a VAE decode to the case sampler. The steps should be as per the checkpoint. 35 for Juggernaut Aftermath. The CFG range is 1.5 to 3, where 2 is the sweet spot. A higher CFG makes the image more vibrant and adds some more details. The sampler and scheduler are as per the checkpoint. Reduce the denoise value to 0.9 for better consistency. Connect the VAE decode to a high-low frequency separation node. Basically, high-frequency components represent rapid changes, such as sharp edges, fine details, and textures. They provide the details that make an image look sharp and clear. Low-frequency components represent gradual changes, such as smooth gradients, large areas of uniform color, and overall shape. They capture the broader structure and overall appearance of an image. After much testing, I found a sweet spot. Keep all values at 32. The detail image and mask will come from the blend layer node added early on, but not directly. I forgot to rename this node. Rename it to Blend Mask Composition. Add a preview bridge from the impact pack. The preview bridge is a live node, where you can mask and send the mask output further along the workflow. This will be our detail image for the frequency detail restore node. Before I proceed, group the nodes as shown. We'll rename the groups later. The thing is, if you don't manually mask and pass on the mask to the detail transfer, there will be an error. So we add a switch here. The mask segment we set earlier on. We will use this as the default pass-through. The preview bridge mask is first and is always recommended. You do not want to replace the whole subject in the final generation. We are doing this so there is no error at the initial run. The third mask option is to load a saved mask, if you don't want to manually draw the mask over the text details repeatedly. So rename for clarity. Again, the first manual mask should only be made over the text, which is all messed up, and any other details missing. The second mask is just to avoid the error, as the preview bridge is empty on the first run. The third mask is where you have already saved everything and just want to use that. Keep the default as 2 and connect with the detailed transfer node. Now let's group the remaining nodes and rename the groups to keep everything organized. Checkpoint and ResAdapter. ICLight. IP adapter. Latent encode selection. Sampling. Conditioning. And finally, masking for details. After we add details, we want to match the original output color. This helps with some text coloring that does not match the relight scene. Change the method as shown. Now, I will add some post-processing nodes that enhance the overall image. The first one is called Auto Adjust version 2. I prefer to keep all values at 0 and reduce the strength to 50. The second post-processing node is Levels. Here, increase the black point to 10. You don't need to change anything else. These two nodes can be applied to any workflow to improve your image. Finally, add a Save an Image Comparer node. Group these nodes together and name the group as Detail Restore and Post-Processing. I forgot to connect the conditioning. Go back to the checkpoint group, and from the ResAdapter, connect the clip to both conditioning nodes. Okay, so I color organized the workflow. It looks neater now. Let's test it. I am using a previously generated prompt from a saved file. As said earlier, the Ollama may generate different prompts upon opening and closing Comfy. By default, I am keeping it at 2. We'll then mask only certain details to show you the actual difference and why you should always mask manually. So, notice how the text details have been transferred. Also, can you see the difference in colors, contrast, and overall image quality? This is because of the 2 post-processing nodes added in the end. Now change the value to 1. And I am going to mask only the text. When you just change the transfer detail mask, it happens very quickly as it does not go through the sampling process again. Let me bring up the image and show you the difference. When the entire subject is transferred, some relight details are lost. Hence, it is recommended that only minor details like text or logos or anything that got distorted during image generation be masked for transfer. The second thing I want to show you is the effect of CFG. Let's choose a different background for the same object. This is at CFG 1.5. Let's increase it to 3. You can see some details, and vibrancy has changed. 2 is around a sweet spot, but again, it depends on the product color, background, and basically what you are going for. This is the product and the background. And this is the final generation. If you look closely, the text has not been transferred correctly. Let me explain the reason and the fix for it. The masking is correct. However, the scale of the product is at 70% and not 100. The text is a bit small. The mask blur is a bit too high for such small text. Reducing the mask blur from 32 to 16 would fix this. Way better. 32 should be used when dealing with upscaled images. But again, it's image dependent. We used an empty latent along with the product and passed it into the case sampler. There are other ways to manipulate the image lighting, such as using directional lighting. Here, when I say normal, I mean black and white. We will manipulate the light source and intensity by creating gradients and passing them through the latent inputs. Add a CR color node and convert the height and width. Make the connection. Use only black and white here. White means the light source and black means shadow or dark areas in the scene. Convert the image to mask. The remap mask range is used to define the light intensity. I prefer to keep it at 0.8 and then increase or decrease as required. Add a mask grow node. The grow value should be 0, increase the blur to 25. Finally, add a mask preview. You can have the light direction vertically or horizontally. Rename the node to linear gradient. If you decrease the max, it reduces the intensity, and increasing it does the reverse. I find 1 to be quite intense in my testing unless I specifically require that brightness level. 0.8 seems to be the sweet spot for me. Now, let's add a radial gradient. Same steps as before. Duplicate all these nodes and make the connections. Again, black and white color only. Okay, so this is just a sample. You can play around with it and change it in any direction you want. The next mask would be a shape mask. I will do a circle only, but you can do a square, triangle, etc. Here, convert the frame's width and height to input. For this, add a grow mask with blur node. Keep the blur radius at 12. Duplicate and connect these two nodes. Yeah, I know the mask blurring is a duplication, but the effect I get when both are there is slightly different. You can bypass one if you like. Adjusting some values. The last mask would be a manual draw mask. Add a CR color panel. This node creates a solid color. Again, black would be the dark areas and white the light. So, I can make a full black background and draw over it manually, which would mean me defining the light areas or vice versa. Duplicate the nodes for intensity and mask blur. For now, let's switch the panel color to black. Add a switch any node and connect the output from each mask type. Rename for clarity. Convert the switch mask to an image. Duplicate the argmax VAE and connect it with the converted mask. Add a switch and connect both the VAE encodes. Rename as shown. Add the nodes to a group called Directional Normal Lighting. Connect the latent switch with the K-sampler, and let's test all 4 of them. This is linear from left to right. To reverse, switch the black and white. Let's check out radial. The shape. You can see how the AI is doing this intuitively. Let's move the light shape a bit towards the left. For the manual mask, just draw in the mask editor. Let's try a lower intensity. For the last part of the workflow, we will add a third latent option, a color mask. The procedure is similar. We create a new group called Directional Color Lighting and add the color bars node. Here choose a color, for example, red and black. Select the orientation and the bar frequency. Connect this to an image Gaussian blur node. Maximize the blur. Duplicate the VAE and add it to the switch. Organize the nodes and test. This is a bit intense. Let's try a more appropriate color, like navy blue. You can play around with the colors and settings to get some pretty creative results. For some products where the product color is essential, you would want to use a whole body mask instead of selective masking. Secondly, it is not necessary to only use a whitish background. We can use this pink pattern background, for example, and reduce the saturation in post-processing. Get the mask segment and invert the mask. Connect it with the mask preview. Connect it to another Auto Adjust version 2 layer. Place the node between the first auto levels and adjust. Increase the strength to 100 and reduce saturation. Keep the node on bypass unless required. This allows you to manipulate the background saturation, contrast, and colors as needed. The second workflow is mostly copy and paste, but you need to see it as we change some things. You can transfer details to an upscaled image without any issue. Once you generate your near SDXL output, use any upscaler of preference. Super, Topaz AI, it does not matter. What matters is that the upscale should be 2x, 4x, or 6x. Multiples of 2 only. No custom resolution and no 1.5x upscale or 3x upscale. You should note that the upscale SDXL image should not be greater than your original product image. We will match the resolution and transfer details as long as the product photo is the same or higher in resolution than the upscale. Otherwise, the transfer will result in blurry details. We have a super upscale tutorial, we'll link that video in the description. To start, load the main workflow and open a new blank workflow. Copy all the nodes I select from this workflow and paste it into the other workflow. We will then build it from there. Rename the background to Upscale. Connect it with a getImageSize node and further connect that to the color gradient. Use a set node for the upscale image. I forgot the product resize node, copy and paste from the other workflow. Add an integer binary operation node. Change the operation to multiple and convert A and B to inputs. Duplicate and connect as shown. Then add impact pack integer and connect to both B inputs. This value is the upscale factor. So if you upscale 2x, put 2x here. Connect with product resize. Add to image group. Name this product resize. And these as background composition. Connect the product resize to both masking inputs. Group as mask. Arrange the nodes as shown. These would be grouped under blend composition and masking. Get the upscale image and connect everything as shown. Name this group detail transfer. Let's test this. Load the upscaled image and the original product photo. And run the workflow. This is because the blend composition node should have the same setting during the SDXL generation in the previous workflow. I did not want to complicate things further and thought it's best to set the values manually. You should probably change the mask blur value to 32 for 4K images. And like before, you can open the preview bridge and mask to transfer selective details. And that's about it. I hope the video was helpful and that you learned something new about ComfyUI. Until next time.